Lesson 6.2 talks about inverse functions. So before we jump into our homework problem, let's talk about inverse functions. When a function is, let's say I have this f of x, and then let's say it's set of some ordered pairs when x is 1, y is 0, or when x is 2, y is 5, when x is 3, y is 7. Let's say this is a very basic function expression. For every function, we have something called domain. Domain means the set of the x values. So if I just find only the x values in this function, so since this function is only made up of these three ordered pairs, the domain will be 1, 2, 3, because these are the only x values. So domain is the x values. And then range of the function will be the y values of this function. So the y value from the first ordered pair is 0. And then we have 5. And then we have 7. So these are the y values. Now, if somebody says that find the inverse of this function, and this is how we show the inverse, f to the power of -1 of x. This means I want to find the inverse of the f function. So the inverse function and the function, all they're going to do is they're going to switch their domain and range. So this point 1 comma 0, here on the inverse, it will be 0 comma 1. So x will be 0, y will be 1. For the second point, x will be 5, y will be 2. On the last point, x will be 7, y will be 3. And this is how the inverse function and the function, they are related. Whatever the x value, it becomes the y value on the inverse. So now if I find the domain of the inverse, all the x values from the inverse, the first x value is 0, the other x value is 5, and the last x value is 7. And then when I look at the range of this function, 1, 2, 3. So the domain on the function becomes the range on the inverse. And then the range of the function will become the domain on the inverse. This will be the relationship between the function and its inverse. Now, we have two tests. We have a vertical line test for functions, and then we have a horizontal line test. So we can decide if something is a function or not by applying a vertical line test. Let's say I have this graph. I need to decide if this is a function or not. So when I apply a vertical line, since the vertical line is crossing with the graph more than once, in this case, it's actually crossing 2 times, I'm going to say, no, this is not a function. So this is actually a graph of a circle. So circles are not functions because when you apply the vertical line test, the line and the graph is going to cross with each other more than once. So it will be a no, it's not a function. Let's think about some other graph. This is a very famous graph in college algebra. This is a parabola. And then when we think about a parabola to decide if this is a function or not, again, I randomly drop a vertical line test. It doesn't matter where you drop it, everywhere it is, it can be anywhere. So it only crosses with the vertical line test, vertical line, and the graph only crosses once. So yes, this parabola shape is a function. So we use the vertical line test to decide if a given graph is a function or not. But horizontal line test it is here to decide if your function is 1 to 1, 1 to 1. So the same parabolic shape, parabola, we know, yes, this is a function because it passes the vertical line test. But when I apply the horizontal line, it crosses with the graph more than once, so this is not a one-to-one function. In fact, whatever the x value here, it generates the same output with the same different x value here. That's what one-to-one means. But for example, when I draw a square root function, this is what the square root function looks like. When I draw a vertical line test here, vertical line, it crosses with the graph only one time, so this will be a one-to-one function. Now, why is it important to be a one-to-one? Because only one-to-one functions, their inverses will be a function. So for example, this one, when you take its inverse, it's gonna look like this. And then it will not be a function. It's not gonna pass the vertical line test. So only one-to-one functions, they will have, their inverse will be a function. So let's start with the assignment problems now. The first question is not about inverse functions. They give us a rational function, and then they're just asking me to find the domain of this rational function. Now, for rational functions, the denominator cannot be equal to 0. So I'm going to take the denominator. In this case, for the first question, the denominator is x squared plus 5x minus 14. I will set this to a 0 to see when this expression becomes a 0. So the factors are x plus 7 and x minus 2. Because when I multiply these two numbers, the answer is negative 14. When I add them up, the answer is 5. So this will become when x is negative 7, and then this will become when x is equal to 2. So for this question, domain is going to be all real numbers, except x cannot be equal to two certain numbers. So we're going to choose D, and then we're going to write the answer in set builder notation. So we're going to say domain is, you can use any x you like. That's what it means, x slash. Domain will be represented by x, but x cannot be equal to negative 7 or positive 2, because for these two x values, the denominator will be equal to 0. And for rational functions, whenever the denominator is equal to 0, the function becomes undefined. So we're going to say the domain is x slash, and x shouldn't be equal to negative 7 or positive 2. That's how we're going to answer number 1. For number 2, it is a question that we're going to fill in the blanks. If every horizontal line intersects the graph of a function at no more than one point, f is a one-to-one function. So this is the horizontal line test. So horizontal line test checks whether your function is one-to-one or not. The third one is, if you have a point where f of 3 is 8, then what is the inverse function when x is 8? Remember, so we have the function and we have the inverse. This is very important, especially if you're going to take some calculus class later. This will be still on the calculus class. So x is 3, y is 8. So that's what we have on the function. X is 3, y is 8. So remember, whatever this point is on the function for the inverse, we need to switch the x and y value. So on the inverse, x will be 8 and y will be 3. And this question is asking for your inverse function. So I need to look at here. When your x value is 8, what will be your corresponding y value? And I'm going to choose just 3, because the x becomes the y on the inverse. That's the rule about, very important rule about between functions and their inverses. For question 4, we have two functions given f and g. First, we're going to calculate f of g of x. So we're going to put the g inside the f. Then for part B, we're going to put f inside the g. And then we're going to decide if these two functions are inverses of each other. So we're going to understand the relationship between the inverse functions and their composite functions. So let's move here, and then let's scroll down a little bit. So I need my f of x to be copied here. F of x is 4x minus 16. And g of x will be equal to x over 4 plus 4. So these are the two functions. First, let's find f of g of x. So this means we're going to put the g function inside the f function. So here's my f function. F function starts with 4, but instead of x, I need to plug in this whole thing, which is x over 4 plus 4. And that takes care of the 4x part, minus 16. So 4 times x over 4, the top 4 and the bottom 4 will cancel out, and I will just get x. and then 4 times 4 is 16, and then minus 16. These two will cancel out. So f of g of x is x. Now for part B, we're going to do the opposite. We're going to calculate g of f of x. So I need to put f inside the g. So I'm going to start with the g function, and the g function is something over 4 plus 4. So instead of the something, the x will be dropped, and instead of x, I need to just bring the whole f function, which is 4x minus 16. Now when I simplify this, 4x divided by 4 is just 1x, 16 divided by 4 is just 4, and then plus 4. These two will cancel out, and I'm just going to get x. Now, we're going to say f of x and g of x are inverses of each other, because this is a rule that we need to understand, because when we did the f of g of x, it was the exact same thing as g of f of x, and they were both equal to the x. So the rule is, when you calculate f of g of x, if that's equal to an x, and g of f of x is also equal to an x, that means f and g must be inverses of each other, because only inverse functions, their composite functions in either direction will be the same thing, and they will both give you an x. So this is how we're going to answer this question number 4. And here you're going to say, but also they have some extra questions here. For f of g of x, once we find the answer as x, do we need to exclude any numbers? No, here the answer is a linear function, right? And then here there is no x in the denominator, so you're going to choose no values should be excluded from the domain. Similarly here, no numbers should be excluded from the domain because we didn't get any x in the denominator. And then you're going to choose, are these inverses of each other or not? You're going to say yes, they are inverses of each other because their composite functions in either direction, they gave us a 5. So number 5 is the last question type we need to cover under this lesson. For number 5, on the homework, we have this function given, f of x is equal to 4x minus 2. First, we're going to find the inverse of this function, and then we're going to find the domain and range of both f and the inverse of f of x. And then we're going to graph both f and f of x, f to the power of -1, and y equals x on the same coordinate planes. So first thing is, if I have a function, how can I calculate its inverse? Step number will be f of x will be changed with y. So instead of f of x, we're just going to put y, because y and f of x, they always mean the same thing. So our problem is y is equal to 4x minus 2. This is what we have, and we want to find its inverse. Next step is we're going to switch the x and y. So when I see the y, I'm going to write an x, and when I see the x, I'm going to put a y. And then the rest of the thing will be the same. Now I'm going to solve this equation for y. So y is still not isolated. The last thing I need to do is to isolate the y will be divide everything by 4. So we won't call this as y anymore. This will be the inverse of the f function. If f is 4x minus 2, its inverse will be x over 4. Or we can just put 1/4 of x, either one is correct. And then plus 2 out of 4, I can simplify the 2 out of 4 as 1/2. So this will be the inverse function. Now, f of x equals 4x minus 2. This is a linear function. For all linear functions, domain is all real numbers. So domain is from -infinity to +infinity. And then for the range, again, this is a linear function. Range for the linear functions will be always -infinity to +infinity. For the inverse function, when we calculated the inverse function, this is still a line, 1/4 of x plus a half. Its y-intercept is half, its slope is 1/4. Since this is still a linear function, the domain will be still -infinity to +infinity, and the range will be still negative infinity to positive infinity. And then you can just graph both of these lines using the y-intercept and slope on this homework question. And then the domain is all set of all real numbers is the same thing as negative infinity to positive infinity. So for this one, you're going to choose B. And then the range will be also all real numbers after we find the inverse. Then for the inverse will be also all real numbers, all real numbers. Then the graph, we're going to graph both lines here using the y-intercept and slope, and y equals x also needs to be graphed here. So this is what it is going to look like once you graph it. This line in the middle is y equals x line. And then this line here, it's y-intercept. I can see it clearly, but for this one, it looks like y-intercept is 1/2, but the other one, steeper line, it has a negative y-intercept. So this is how you're going to graph these questions on 6.2.